All right, so let's talk about a good way of collecting data so you can start to graph it. And we'll start with talking about categorical data. So imagine I wanted to study, say, a class's favorite hot beverage out of the following. So coffee, tea, and hot chocolate. Maybe for whatever reason, I wanted to see what my class's favorite beverage was. So I would ask each one of them. Now, a really bad way of doing it is just to ask each person and writing it down and write it down in a row. If C was coffee, T was tea, and H was hot chocolate, you can imagine asking the first person, they'd say coffee, so you'd put a C, and then tea, you'd put a T, coffee again, hot chocolate, coffee, coffee, tea, hot chocolate, tea, tea, coffee, hot chocolate, tea, coffee, coffee, hot chocolate, coffee, coffee. You could imagine if I did something like that, well, it's kind of really hard to see, well, how many people in the class like coffee? I'd have to go in and have to count how many C's I've already had. So maybe a better thing to do instead of doing something like this is to organize your data into a little tally chart. So imagine I asked the student, I asked them what their favorite beverage out of these three was, and they said coffee. So maybe I could just do a little tally thing. So I put a little tick there. So that's one tick. Let's say another student said coffee. Okay. So the second student, I'll put another tick. And the third student, if they like hot chocolate, I'll put a tick there for hot chocolate. Tea, fourth student wants tea, so I'll put a tick for the fourth student. And let's say fifth is coffee, sixth is coffee, seventh is hot chocolate, eighth is coffee, ninth is tea, 10 is tea, and so on. So I'm going to just pause the video right now and just put in a bunch of ticks like I asked an entire class what their favorite beverage was out of these three. So there we go. After asking an entire class worth, let's say I have the following data. So under frequency, here's frequency. That's just the number of ticks I made in each category. So how many of my students like coffee the best? So that's 5, 10, 15, 20, 25, 28. So I'll write 28 here as the frequency. That's how many students are in that category. T, if I count T, I get 5, 10, 15, 19. So let's say 19 students like tea the best, and 12 students like hot chocolate. And how many students in total do I have? Well, let's count them up. If we add these numbers, we get 28 plus 19 is 47. 47 plus 12 is 59. So let's say there are 59 students that I surveyed. And then the relative frequency, well, the relative frequency is just the percentage in each category. So we know there are 59 students in total, so I need to figure out what 28 over 59 is, and then convert that to a percentage. So I'll figure out that as a decimal, and then multiply by 100%. Maybe I'll do that down here. So 28 over 59 times 100%. And that gives me, rounded to one decimal place in the percent, is 47.5%. So that's the relative frequency here, 47.5%. For T, it's going to be 19 over 59 converted to a percent, which is going to be 32.2%. Again, just doing the equivalent calculation like down here. And finally, 12 over 19 12 over 59 is 20.3%. Okay. And you can check, if you add these up, 47.5, 32.2, and 20.3, you should get very close to, in this case exactly, 100%. I'll make a little note here. You might have a little bit of error. You might be off by 1 or 2 units that you round to, just because of rounding error. So it might be off by a few rounding units. In this case, it was tenths of a percent, since we rounded to the nearest percent. Due to rounding error. So if you get something like 99.9% or 100.1% or something like that, that's okay. And that is a tally chart. So if we had this, this study of figuring out the favorite drinks out of these 3 drinks of a class of students, we know that 28 of the 59, or 47.5%, prefer coffee. 19 out of 59, or 32.2%, prefer tea. And 12 out of 59, or 20.3%, prefer hot chocolate. And now what we can do is we can turn this into a couple of different types of graphs. So I want to talk about one type of graph called a bar graph or bar chart. And this is pretty straightforward. It's really good when you're concerned with the actual number of people in each category. So it's good for displaying actual number in each category. And the way you do it is down the bottom here, we are going to have all of our categories. In this case, we have 3 categories, coffee, tea, and hot chocolate. So we're going to space them out as evenly as possible on our x-axis. On our y-axis, we're going to have possible frequencies. Note that I went up in multiples of 5 here. If you're just sketching it, you have to kind of estimate what's a good multiple to go up for each tick in order for it to fit on your page. So in this case, it kind of made sense to go up by 5s. If I went up by 1s, well, that'd be too big. You'd imagine this would be 1, 2, 3, 4, 5, 6, and to get all the way up to, say, 28, well, 7, 8, 9, 10, I'm way off the page already. If I went up by 20s, let's say, 20, 40, then all of my graphs would be in this little tiny section. It would be kind of hard to see the difference. So you want to pick a reasonable scale here. So I went up by 5s. And so what I'm going to do, and I'm just going to sketch this by hand, but you're going to draw bars for each of these categories. So if there are 28 students that like coffee, I'm going to go up here to 28. So 28 is somewhere around here, let's say. 28. I'm going to draw a nice bar. And imagine this is all equal width. It goes up to 28. So that's the number of students that like coffee. And just by looking at this graph, I can say that it's 28 students that like coffee. And imagine maybe this 28 wouldn't be there in your final graph, but it's kind of easy to estimate. Well, it's between 25 and 30, kind of halfway, but just a little bit over. So 28 seems pretty reasonable. There are 19 people that like tea. So 19 is somewhere around here. There's 19. So I'm going to draw a bar, and I'm going to keep the width the same. Imagine if, maybe I'll do it first incorrectly. Imagine if I didn't keep the width the same. Imagine if I made the T-bar significantly wider than the coffee bar. Well, right now, it looks like way more people like tea than like coffee. We're drawing this in 2 dimensions, so our brain kind of uses all of those dimensions to interpret the graph. So here, even though the bar doesn't go up as high, to our eyes, it looks like there are more people in the tea bar than in the coffee bar, which isn't what we want to express. So I'm going to erase this. And I want to go up to 19, but with a bar. And imagine that these are straight with a bar that goes up to 19. And notice that there's space between our bars. We don't want to confuse a bar chart with something we're going to learn later called a histogram. So we want to have space in between these to indicate that the categories are separate. And of course we want roughly, and if we're doing this professionally, we want equal space between each of our bars. So there are 12 people that like hot chocolate. 12 is around here. So the hot chocolate bar is something like that. And that is a hand-drawn bar graph for our data. Now imagine maybe I wanted to split these categories up a little bit, and I wanted to look at males and females that like each of these: coffee, tea, and hot chocolate. So imagine out of the 28 coffee drinkers, so let's say we'll have male and female category. So out of those 28, let's say 18 males like coffee and 10 females like coffee. With tea, let's say it's 7 and 12. And with hot chocolate, let's say it's 6 and 6. So we can kind of draw a kind of like a two-way bar graph that indicates this data. So let's go ahead. What we're going to do, it's going to be the same idea. We don't have to go all the way up to 28 anymore. We only have to go up to 18. So maybe let's go up by 5s again, but let's make our spaces a little bit bigger so it's a little bit easier to kind of see what's happening. There we are. So now with our categories, say this is coffee, I'm going to have a bar for each of the 2 other categories, male and female, in each of these categories. So coffee, tea, and hot chocolate. Okay, so what I'm going to do is I'm just going to put the bars right next to each other here. And I'll put a little coding first. So maybe I'll say I'll use green bars for male and red bars for female. So let me put a little thing here. So red is female. And we'll do female first, I guess. So 10 female students like coffee. So I'm going to draw a bar. It goes up to 10. 12 female students like tea the best, so I'm going to go up to 12 here. That's roughly 12. And finally, 6 female students like hot chocolate. That's about there. So there is the graph for females, and for males I'll do in green. So I'll just change my color here to green. Put a little legend to make sure that people know what it means. And we have that 18 male students like coffee the best. So there is my 18. We have 7 male students like tea the best, so 7 is roughly there. Notice that this is just sketched by hand, but the idea is to make all bars the same width so that your eye looks at it and doesn't see any difference between the width of the bars. And hot chocolate is 6, so that is there. In fact, looking at this, I'm going to erase the tops of these 2 bars because they look more like maybe 6.5 than 6. So that's probably more like there. And then the green one will be here. All right. And looking at this chart, you can see that, well, 10 female students like coffee the best, 18 male students like coffee the best. And you could imagine if you were given this chart and I asked, well, how many students in total like coffee the best? Well, you'd say, well, there's 10 female, 18 male. So there are 28 students that like coffee the best, etc. And I could ask questions like, well, how many students are male? Well, you'd go to the male category to be 18 plus 12, plus 7. 18 plus 7 is 25, plus 6 is 31. So that's how these bar graphs work. And I'm leaving one important part. We should give them a nice title. So I'll put a little note down here. Whenever you make a graph, give it an appropriate title. So maybe this one could be something like number of students that prefer each hot beverage. And maybe for the second one, it could be number of male and female students that prefer each hot beverage. Another great type of chart to display categorical data are pie charts. And this is great if you want to express categories as a proportion of the whole. The idea is your circle or your pie is the whole, and you want to express the proportion of each category in that whole by representing that proportion by a slice of the pie. So the question is how to figure out what the slices of the pie should be. How big are those slices? So if the number of students, out of the 59 students, 28 of them prefer coffee, that's 47.5%. How can we figure out 47.5% of our circle? Well, kind of the easiest way is to do it as a proportion. So remember that a circle has exactly 360 degrees. So I'm going to show you 2 different ways to do it. So to figure out, or to determine the angle for each pie slice, you can either do the percentage times 360 degrees, or the second thing you can do is you can do the proportion, so part over whole equals x over 360, and solve for x. Either one will do. I'll do one each way. So the first one, let's figure out the size of the slice for coffee. Well, it needs to be 47.5% of our circle. So if we were to draw this, obviously we'd need a protractor in order to actually draw this, but let's figure out the angle. So we need 47.5% of 360, so it'll be 0.475 times 360, and we can either do this by hand, or if you're allowed a calculator, you can use a calculator, and we get 171 degrees. Remember, an entire circle is 180, so this is just less than half of my circle. So I'm just going to estimate this, but you could determine this exactly by using a protractor. But that is roughly 171 degrees. Maybe I'll just mark this in here. So this angle here is 171 degrees. Now to determine the second one, let's do it the other way. So it's 19 over 59 equals x over 360. We need to solve for x here. Remember, this is a part-whole comparison. So the part to the whole of the student, so 19 out of 59, we want that to be in proportion to the part of our circle over the whole of our circle. So that's what we're doing here. It's just a little proportion calculation. So if we want to solve for x, we're just going to cross multiply, and we get that 59x equals 6840, and divide both sides by 59, and we get x equals roughly 116 degrees. So 116 degrees, maybe I'll make this slice here. So 90 degrees is a quarter of the circle, so I want just a bit more than a quarter. So it'll be somewhere around here. So this would be 116 degrees. And finally, you could work out the other one, but we know, well, it's just going to be the rest of the circle. So it's going to be 180 minus the 360, not 180, that's half a circle. 360 minus the 171, so that's 189, minus the 116, that is 89 minus 16, so that's 79 minus 6, so that is 73. So this here should be 73 degrees. Now it's always a good idea to color each section a different color so that people know what each slice represents. So we'll go to our coloring tool. And if you're doing this using computer software, we'll do all of this for you, but it's good to know where all this is coming from. So let's color, maybe coffee will be red, and I'll do a little legend after I color everything in here. So there's red. Let's do tea with green. So there's green. And we'll do hot chocolate blue. And there is our pie chart. So we'll do a little legend. So red will be coffee. Blue was hot chocolate. And green was tea. And again, we finished this graph, so it's a good idea to give it a title. How about proportion of students that prefer each of the hot beverages, we'll say. So there's the title of our graph. Now with pie charts, it's kind of hard to see actual numbers. Like looking just at this chart, you can't see that, oh, it's exactly 28 students that prefer coffee. But just by looking at this, it's really easy to see that it's just below half of my students. So while it's not as good for giving numbers, it's really excellent to show proportions. But if you remember with the bar graph, it was hard to see proportions. It was hard to see that almost 50% of the students preferred coffee because it was just a bunch of bars next to each other. So if you're looking at displaying proportions, pie charts are a good way to go. If you're looking at displaying actual numbers, if that's important to you, you should look at bar graphs. And I will say, to end this little bit, there are many other different types of charts out there for categorical data. We're not going to cover them, but there's hundreds probably. And if you're interested in displaying categorical data in a interesting and informative way, it's a good idea to kind of research these different ways of displaying categorical data in a chart.